Hello children, in this video I am going to discuss grade 10 mathematics chapter 6 triangles. In this chapter the first topic is similar triangles. What are similar triangles? Triangles which have same shape but not necessarily same size. In the similar triangles the corresponding angles are equal and the corresponding sides are in the same ratio. So here if you observe the corresponding angles are equal, x and are equal, y, z, and the ratios of corresponding sides a by p is equals to b by q is equals to c by r. So we can say that these two triangles are similar. We can check the similarity of triangles by three types of similarities: angle similarity, side similarity, and side angle side similarity. The properties are here the same. The ratios of corresponding sides should be equal and the corresponding angles are equal, and these are the examples for the similar triangles. If triangles are similar, then the ratios of the corresponding sides are equal to each other. Angle similarity. Two triangles are similar if they have two pairs of corresponding angles that are congruent. So here in triangle AJM and triangle UOT, angle A is equals to angle U, angle M is equals to angle T. So two pairs of corresponding angles are equal. So we can say that triangle AJM is similar to triangle UOT by angle similarity. This is the symbol for similarity. Next similarity is side angle side similarity. In a triangle, if the ratios of two corresponding sides are equal and the included angle is equal, then we will say that those two triangles are similar under side angle side congruency. If you observe here, AR by ME is equals to AP by MO. AR by MP 17 by 51 which is equal to 1 by 3. Here 37 by 111 it is also equal to 1 by 3. And the included angle of these two sides 47 degrees is equals to 47. So we will say that triangle ARP is similar to triangle AMEO under SAS similarity. Next one, side similarity. If two triangles have proportional sides, then they are similar under SSS similarity. See here, the ratios of corresponding sides are equal, 15 by 30. Here, these two are corresponding sides, the ratio is 1 by 2. And these two corresponding sides ratio is also 1 by 2. Here also it is 1 by 2. So, triangle LFO is similar to triangle IHT under SSS similarity. The first theorem in this chapter is basic proportionality theorem. The statement of the theorem is a line parallel to one side of a triangle divides the other side in equal proportion. So here if a line is drawn which is parallel to one side of a triangle, then this line divides the other two sides in same ratio. Here D is a line which is drawn parallel to BC. What are the other two sides? AB and AC. So it divides AB and AC in the same ratio. AD by BD is equals to AE by EC. To prove this, as D is a line which is drawn parallel to side BC, join DC and BE. Join DC and BE and also draw a perpendicular line DN onto AE and EL onto the line AD. Now take the area of triangle ADE. Triangle ADE area is equals to half into base into perpendicular height. So here we can take AD as base and the perpendicular height is LE. So area of triangle ADE is half into AD into EL. In the same way, area of triangle BDE. Triangle BDE is base half into base BD into the perpendicular height of BD is also LE only, EL. Here half and EL got cancelled, AD by AB is left. Again take area of triangle AED by taking AE as base, because here also this AE also is having the perpendicular height. So this side also can be taken as base. So again area of triangle ADE is half into AE into DN and area of triangle CDE with base EC is half into EC into the same perpendicular height DN. Here half and DN got cancelled, AE by EC is left. Now here from 1 and 2 equations, in LHS part both the numerators are same. So if the denominators are also same, then RHS will be equal to each other. So let us observe area of triangle BDE, area of triangle CDE. Look at the triangles BDE and CDE. Both the triangles are having the same base DE and they are lying in between the parallel lines DE and BC. In grade 9 we have learnt a theorem. Two triangles which have same base and lies between parallel lines will have the same area. So what can you say about the area of triangle BDE and CDE? Both are having the same base BD and lying between parallel lines DE and BC. So we can say that area of triangle BDE is equals to area of triangle CDE. Now both the LHS part is equal, so RHS is also equal to each other. AD by DB is equals to AE by EC. So here we have proved that if a line drawn parallel to one side of a triangle, this line DE is dividing other two sides in same ratio. AD by DB is equals to AE by EC. And then the next theorem is converse of basic proportionality theorem. The statement is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So this is converse of the theorem. Take a line DE which is dividing the other two sides of a triangle in same ratio. AD by DB is equals to AE by EC. Now we have to prove that this line is parallel to the third side BC. DE is parallel to BC. To prove that, first let us think that DE is not parallel to BC. So there should be a line which is parallel to BC. Let us take that line as DE dash. Let us take DE dash is parallel to BC. So by Thales theorem, what is the condition here? If a line is parallel to one side of a triangle, it divides other two sides in same ratio. So what are the ratios here? AD by DB is equals to AE dash by E dash C. This is the ratio. Now what is given in the question? In theorem statement, it is given that AD by DB is equals to AE by EC. So from these 1 and 2 equations, LHS is same. So RHS also will be equal. Now add 1 on both sides. Then AE dash by AE dash plus E dash C by E dash C is equals to AE plus EC by EC. So here look at this. AE dash by E dash C. What is AE dash by E dash C? It is AC. AC by E dash C is equals to AE by EC is also AC only. AC by EC. AC got cancelled. We got here EC is equal to E dash C. But is it possible? Can EC and E dash C will become equal? In which case they can be equal? If E and E dash both are on the same point, then these two values will be equal. As we got the same condition, here we can say that we have to conclude that E and E dash coincide with each other. So as we have taken DE dash is parallel to BC, E dash is nothing but E. So DE also is also parallel to BC. So we have proved that if a line divides two sides of a triangle in same ratio, that is parallel to the third side. The next theorem is to prove the angle similarity. In two triangles, corresponding angles are equal, then their corresponding sides are in the same ratio and hence the two triangles are similar. So here he gave that the corresponding angles are equal. Angle A is equals to angle D, angle B is equals to angle E and angle C is equals to angle F. Now we have to prove that the ratios of corresponding sides are also equal and hence they will become similar. Because if the ratios of corresponding sides are equal and if the corresponding angles are equal, then they will be similar, no? So let us prove that. To prove that, let us draw a line PQ in triangle DEF such that AB is equals to DP and AC is equals to DQ. So here these two lengths are equal and these two lengths are equal. Now if you observe these two triangles ABC and DPQ, angle AB is equals to DP, that is from our construction. Angle A is equal to angle D, that is given in the question, and AC is equals to DQ, that is also from our construction. So by SAS congruency you can say that triangle ABC is congruent to triangle DPQ. By CPCT, angle B is equals to angle P. But what is given in the question? Angle B is equals to angle E. So by combining these two, we can say that angle P is equals to angle E. These two angles are equal. These two angles. So, if these two angles are equal, so what can you say about the lines PQ and EF? Observe these two angles. They are the corresponding angles made by these two lines and the transversal DE. And the corresponding angles became equal. So, these two lines are parallel to each other. PQ is parallel to EF. Now, if PQ is parallel to EF by Thales theorem, if a line is drawn parallel to one side of a triangle, it divides other two sides in same ratio. dP by PE is equals to dQ by QF. Here, take the reciprocals of these two ratios. PE by dP is equals to QF by dQ. Add 1 on both sides. Then we will get dE by dP. dE by dP is equals to dF by dQ. dE by dP is equals to dF by dQ. From this, and by construction, what can you say? What is the construction we have taken? dP is equals to AB, no? So, this dP by dE can be written as AB by dP. And dQ is equals to AC. So, dQ by dF can be written as AC by dQ. So, similarly, we can also prove that AB by DE is also equal to BC by EF. Now, what did we get? The AB by DE is equals to, by combining these equations, we can say that AB by DE is equals to AC by DF is equals to BC by EF. So, we have proved that in triangle ABC and DEF, the ratios of corresponding sides are equal. Then, as already given that angles are equal, here we have proved that ratios of corresponding sides are equal. We can say that triangle ABC is similar to triangle DEF. And the next theorem is SSS criteria. In two triangles, the sides of one triangle are proportional to the sides of the other triangles, then their corresponding angles are equal, and hence the two triangles are similar. In previous theorem, it is given that angles are equal, and we have proved that the ratios of corresponding sides are in proportion. Here, it is given that ratios of corresponding sides are in proportion. We have to prove that the corresponding angles are equal, and hence the triangle is similar. The triangles are similar triangles. Here also the same procedure. Draw a line PQ such that AB is equals to DP and AC is equals to DQ. Now, by Thales theorem, you can say that it is given that AB by DE is equals to CA by DF. Now, what is AB is equals to? From our construction, it is equal to DP. So, this equation becomes DP by DE is equals to DQ by DF. Take the reciprocals and subtract 1 on both sides. Then we will get DE minus DP by DP is equals to DF minus DQ by DQ. That is equal to PE by DP. DE minus DF. DE minus DP is equals to PE. DE minus DP is equals to this part PE. PE by DP is equals to QF by DQ. Take the reciprocals. DP by PE is equals to QF by DQ. See, DP by PE is equals to DQ by QF. So, by converse of Thales theorem, what can you say? This line is dividing these two sides in same ratios. So, these two lines are parallel to each other. PQ is parallel to EF. Now, for lines PQ and EF with transversal as PE, these two ratios will be, these two angles will be equal. By corresponding angles axiom, we can say that angle P is equals to angle E and angle Q is equals to also angle F, because these two lines are parallel and these two will be transversals. Now, take triangles DPQ and DEF. D is common, and angle P is equals to angle E, angle Q is equals to angle F. So, by angle similarity, we can say that triangle DPQ is similar to triangle DEF. If they are similar, the ratios of corresponding sides are equal. DP by DE is equals to PQ by EF is equals to DQ by DF. Now, but it is given that AB by DE is equals to BC by EF is equals to CA by DF. But we know that from our construction, AB is equals to DP and CA is equals to QD. So, replace here. AB, instead of AP, we can write DP by DE is equals to BC by EF is equals to, instead of CA, we can replace DQ by FD here in this. Now, from 2 and 3, we can take that BC by EF is equals to BC by F is equals to PQ by EF. Now, EF got cancelled. BC is equals to PQ. BC is equals to PQ. Now, from ABC and DPQ, AB is equals to DP from our construction. AC is equals to DQ, it is also from our construction. BC is equals to PQ, here we got this value. So, ABC and DPQ are congruent under SSS congruency. By CPCT, angle P is equals to angle P. Again by CPCT, angle C is equals to angle Q and angle A is equals to angle E, as it is the common angle or corresponding angles. Now, but what is given in the question? But from first equation, what did we get? Angle P is equals to E and angle Q is equals to F, no? But here we got that angle B is equals to P. So, can we conclude that angle B is equals to angle E? Angle from these three, see, by these three equations we can say that angle B is equals to angle E and angle C is equals to angle F. So, we can say that all the corresponding angles are also equal. Already we got that angle A is equals to angle D. So, as he gave that ratios of corresponding sides are equal and we have proved that corresponding angles are equal, we can say that triangle ABC is similar to triangle. Then the next theorem, theorem 6.5. If one angle of a triangle is equal to one angle of other triangle and sides including these angles are proportional, then the triangles are similar. Here angle A is equal to angle D and the sides including angle A and D are in proportion. AB by DE is equals to AC by DF. We have to prove that these two triangles are similar. For that, draw a line PQ such that AC is equals to DP, AB is equals to DP and AC is equals to DQ. Now, by converse of Thales theorem, it is given in the question that AB by DE is equals to CA by DF. But from our construction, AB is equals to DP, AC is equals to DQ. So, replace them. Take reciprocals of these two fractions. Subtract 1 from 1 on both sides. Then, we will get that PE by DP is equals to QF by DQ. Again, take the reciprocals. So, here DP by PE is equals to DQ by QF. By converse of Thales theorem, as this line is dividing these other two sides in same ratio, then lines are parallel. PQ is parallel to EF. The corresponding angles are equal. Angle P is equals to E, angle Q is equals to F. So, from triangle ABC and DPQ, A and D are equal, B is equals to P, C is equals to Q. So, we can say that AB is equals to DP, included angle is equal, AC is equals to DQ. We can say that ABC is congruent to triangle DPQ. By CPCT, B and P are equal, C and Q are equal. Then, but from 1 we got that these two angles and these two angles are equal. So, angle B will be equal to angle E and angle C will be equal to angle F. So, we have proved that all the three angles are equal here. So, by these two angles became equal now by angle similarity, we can say that triangle ABC is similar to triangle DEF. And then the next theorem is Pythagoras theorem. The statement of the theorem is, in a right triangle, the square of hypotenuse is equal to the sum of the squares of other two sides. To prove this, take a right angle triangle ABC with right angle at B. Now we have to prove that ABC right angle at B. We should prove that hypotenuse square is equals to sum of the squares of other two sides. AC square is equals to AB square plus BC square. To prove this, we have to let us draw a perpendicular line BD on AC. That is, BD is perpendicular to AC. From the right angled vertex B, we have to draw a perpendicular line onto the hypotenuse. Now, observe triangles ABD and ABC. ABD and ABC. Here, angle BAD is equals to angle BAC. It is the common angle for both the triangles. And angle ABC is 90 degrees. Angle ADB is also 90 degrees. So, by angle similarity, we can say that triangle ABC is similar to triangle ABD. Now, if two triangles are similar, their corresponding sides are equal, no? Ratios are equal, no? So, AD by AB is equals to AB by AC. Now, by cross multiplying, we will get AB square is equals to AD into AC. Again, take triangle BDC and triangle ABC. Triangle BDC and triangle ABC. Here, angle C is common, and in triangle BDC, the angle D is right angle, and in triangle ABC, angle B is right angle. So, again by AA similarity, these two triangles are also similar to each other. Now the ratios of corresponding sides are equal. DC by BC is equals to DC by BC is equals to BC by AC. BC by AC. By cross multiplying we will get BC square is equals to AC into DC. From 1 and 2, add 1 and 2 equations, LHS plus LHS, RHS plus RHS. Here AC is common in both the terms. Take AC as common, AD plus DC. What is AD plus DC from the figure? It is AC. So here AB square plus BC square is equals to AC into AC, that is AC square. So we have proved that AB square plus BC square, the sum of the squares of two sides, is equal to the square of hypotenuse, AC square. So this is the Pythagoras theorem. Proof of Pythagoras theorem. And then converse of Pythagoras theorem. The statement is, in a triangle, if a square of one side is equal to the sum of the squares of other two sides, then the angle opposite to the first side is a right angle. This is the converse of Pythagoras theorem. Theorem proof is deleted from the syllabus. Just I am explaining the statement. In a triangle, if the square of one side, if the square of this side is equal to sum of the squares of these two sides, then the angle opposite to this first side is a right angle. So this angle will be the right angle. So that's all, children. I have explained all the theorem proofs in this chapter. Thank you.